So hello guys, with the name of God Ram Ram. As we know that the Meesho online assessment has happened and they asked a nice question on trees, and I have already taught that variation in the tree course. But most people might not have done that part of the course, right? So I will teach you again today. Now let's do the easy version. You are given an array, guys. You have to find the count of subarrays whose sum modulo m is 0. So start writing in your book whatever I'm showing you. So if I give you an array, let's say 2, 3, 5, 8, and m value is 2. How many subarrays are there in this array? Or let's take one based indexing. How many subarrays are there in this array whose sum is divisible by 2? Whose sum modulo m should be equal to 0. How many such subarrays are there? One valid subarray is only 2, because 2 divided by 2 is 0. Then 3 comma 5 is also a valid subarray. Why 3 comma 5 is valid? Because 3 plus 5 is 8. The sum of this subarray is 8, and it is divisible by m. M is what? 2. 8 mod 2 is equal to 0. 8 is divisible by 2, right? So 3 comma 5 is a valid subarray. Next valid subarray will be 2 comma 3 comma 5. You can calculate the sum of 2 comma 3 comma 5. 10. 10 is divisible by 2. It should be divisible by m. M is equal to 2 in this case. 3 comma 5 comma 8. Whatever is the sum of 3 comma 5 comma 8, it is also divisible by 2. Then 2 comma 3 comma 5 comma 8. Whatever is the sum of this part, that is also divisible by 2. Then only 8. This is also divisible by 2. So subarray means any contiguous part of the array. How many subarrays of this array are divisible by m? That's what question is telling us to find out. So 1, 2, 3, 4, 5, 6. I can see 6 subarrays here whose sum is divisible by 2. Okay. Now I'm not sure about you people, but I can see 6 subarrays. 1, and then yeah, 2, 3, then 4, 5, then 6. Yeah. So guys, open the Google chat. How many subarrays do you see in this array whose sum is divisible by 2? Okay. Good. Fine. So guys, what will be the brute force solution? Pretty easy, right? Run two nested for loops. You will run two nested for loops. You must be knowing what I'm trying to say. Then by running two nested for loops, what's going to happen? Iterate each subarray. Iterate each subarray. If sum of the part from I to j mod m is equal to 0, then what will you do? This is a valid subarray, right? You will do count equal to count plus 1. I'm telling things very directly because I understand that you are not a beginner. And then you will print the count. So hopefully you guys understood what I was trying to say here. Just run two for loops, right? Let's assume one based indexing of the array. So I will go from 1 till n. Then inside this, j will go from I till n. Before writing the J loop, I will initialize sum equal to 0. Inside the J loop, I will write sum equal to sum plus A of J. So after writing this line, this sum is holding the sum of all the elements from I to J. Now you can write the if condition. If this sum divided by m is equal to 0, do count plus plus, means this subarray is valid. So what is the time complexity, guys, of this solution? I will open the Google chat, you have to tell me. And if anyone did not understand this basic solution, let me know. So guys, are you ready to tell me the time complexity in the Google chat? Everyone tell me the time complexity of this solution in the Google chat. What do you guys think, guys? Okay, fine. N square. Okay. Because we are running two for loops, right? Guys, is there anyone who has doubt in this basic solution of running two for loops, getting the sum of all subarrays and checking if the sum mod m0 then c++? So it's n square basic solution, right? React with emoji if everyone understood and no one has any doubt in this. Anand Pal, do you really understand? Okay. Optimization is very important here. So let's directly deal with optimization, guys. Okay. So obviously you are Kumar case student. You must be knowing things already. I think the same question, like similar question, is there in the course. Okay. So guys, you know na, in the hashing problems, wherever we have to do some kind of optimization, we have to solve this problem in O of n. We will sit at an index j and we will imagine and count all the valid subarrays ending at index j, and that will solve the whole problem. Okay. Run only one for loop j. At each index j, calculate the count of valid subarrays ending at index j. So guys, if you're able to achieve this task, then the job is actually done, right? If I take an array for you, this is your index j, your m value is 2. Can everyone write in the Google chat which are the subarrays which are ending at index j? I have fixed the index j. Which are those subarrays, guys? Which are ending at index j? Some people don't even know what is the meaning of subarrays ending at index j. My j is pointing to 8. So guys, which are the subarrays ending at index 8? Ending at index j. This subarray, then this. Everyone has to write in the Google chat, including Anand Pal, the subarrays which are ending at index j in this particular case. So guys, start writing. Which are the subarrays which are ending at index j? Not the number. I want the exact subarrays. Which are those subarrays? Yes, Aditya Shankar Jha. 8. Congratulations emojis for Aditya Shankar Jha. Only he was able to give correct answer. So always imagine like that only. It is 8. It is 8, 2, 8, 5, 2, 8, 2, 5, 2, 8. Okay. Fine. Great. Now, which of them are divisible by m? They will be the valid subarrays ending at index j. This is valid, yes. 8 is divisible by 2. 2 plus 8 is also divisible by 2. 5 plus 2 plus 8 is divisible by 2. No. Is 2, 5, 2, 8 divisible by 2? 7, 8, 9? No. So only two valid subarrays are there ending at index j which are divisible by m. So subarrays, valid subarrays ending at index j is 2. So like guys, like this for each j, I will somehow calculate the valid subarrays ending at index j, and then I will do the sum of all. First, I will calculate all the valid subarrays ending at index 1, then all the valid subarrays ending at index 2, then all the valid subarrays ending at index 3, then all the valid subarrays ending at index 4, till the end. All the valid subarrays ending at index n. Okay. So, what will be the answer? Till the end. That's it. So, these things are nice and you enjoyed it. Great job. Now, guys, please make sure you listen to me carefully and do the things carefully. But, guys, how will we calculate all the valid subarrays ending at that particular index? The trick is this. Let's assume a very big array. I am at index j, guys. I am at index j, guys. Okay? Yeah. I am at index j, guys. I am where? I am enjoying at index j. I'm enjoying at index j, guys. I'm enjoying at index j. Okay? This is index 1. This is index 2, guys. This is index 1. This is index 1 and this is index 2. This is index 1 and this is index 2. Power off. This is index 1 and this is index 2, guys. Okay? Okay. Let's say m is equal to 2. Okay? M is equal to 2. When you divide these two numbers, na, when you do this number mod m, na, you are not getting the remainder as 0. You are getting the remainder as 1, guys. You are getting the remainder. Let's assume that when the first two numbers you add them and you divide them by 2, you get a remainder as 1. Okay, sir, we are getting the remainder as 1. Fine. Fine. And guys, can you assume that in this particular case, na, the first number and second number when you add, na, and you do divide them by m, which is 2, you get the remainder as 1. Now let's assume that the same thing happens for all the elements from 1 to j also. So we are assuming that this thing is happening. What are we assuming? कि बेटा अगर पहले दो नंबर को ऐड करके मैं अगर 2 से डिवाइड करूंगा तो 1 रिमाइंडर आ रहा है, ऐसा आप अज्यूम कीजिए. और फिर बेटा मैं अगर 1 से लेके j तक सारे एलिमेंट्स को भी ऐड करके m से डिवाइड कर रहा हूं तो 1 रिमाइंडर आ रहा है. इसको बोलते हैं अज्यूमिंग. अज्यूम तो कोई भी कुछ भी कर सकता है ना. चलो कोई नंबर यहाँ पर डाल ही देते हैं. 1 की जगह 1 लिख देते हैं, 2 की जगह 2 लिख देते हैं. अरे तो मानते हो कि नहीं मानते हो कि 2 और 1 3 होता है. 3 को 2 से डिवाइड करोगे तो रिमाइंडर क्या आएगा? बचपन में नहीं पढ़ाया था आपके पेरेंट्स ने? 2 1 2 टीचर ने. ये देखो 1 रिमाइंडर आया. So basically I'm saying that bro, assume that the first two numbers, when you divide their sum by 2, you get the remainder as 1. And if you sum all the numbers till j and divide by 2 again, you will get remainder 1 only. विश्वास नहीं तो करके देख लो. 1 और 2 और 8 और 8 और 0 कितना होता है बेटा? 16 17 18 19. 19 बटे 2 रिमाइंडर 1 आ गया ना. So guys, everyone has to write agreed in the Google chat if they agree that in this array The sum of first two numbers mod m is 1 and the sum of first j numbers mod m is also 1. Everyone write agreed in the Google chat if everyone agrees with this information. Everyone has to write agreed. Okay. So guys, whenever this thing happens, something important also happens. Aman Verma. If the first two numbers are giving modulo m value as 1 and the first j numbers are also giving modulo m value as 1, then it is guaranteed. This no one has taught so clearly. Then it is guaranteed that the numbers from index 3 to j, if you divide them, if you do them modulo m, it will come as 0. The middle part will be divisible by m. This is the mathematical theorem. मेरे कहने का मतलब ये है कि ये पहले दो नंबर जो थे ना, ये m से डिवाइड नहीं हो रहे थे, ठीक है, इनका रिमाइंडर 1 आ रहा था, फिर मैंने तीन नंबर डाले, बट ये टोटल अभी भी इनका रिमाइंडर वही आ रहा है। मतलब ये जो बीच का पार्ट है ना, ये बीच का पार्ट पक्का m से डिवाइड होगा। इसको मॉड m करोगे तो 0 आएगा। देखो आ ही तो रहा, 8 + 8 + 0 व्हाट इज 16, 16 mod 2 is 0. So guys, this is the basic theorem, okay, that if sum of the numbers from 1 to I mod m is, let's say, y1. Okay, sum of the first I numbers, guys, when you do modulo m, you get y1 as remainder. And let's say when you do the same thing for 1 to j, where j is bigger than I, ये अपना I समझ लो और ये अपना j समझ लो। मैं बोल रहा हूँ पहले I नंबर को ऐड करेंगे तो भी वही रिमाइंडर आ रहा है, पहले j नंबर्स को ऐड करने पे भी वही रिमाइंडर आ रहा है। And if you do the summation from the numbers from 1 to j and you do its modulo m, and the same remainder is coming. This means, this means, this means that the part, the middle part from I plus 1 till j is divisible by m. So guys, you are able to locate a subarray which is divisible by m. अब कोई कोई डेढ़, like there will be some smart people who will say, sir, what is the proof for it, sir? बताते हैं, लोड मान लीजिए। ये वैल्यू क्या आ रही है? ये वैल्यू आ रही है 3, ठीक है, और ये वैल्यू क्या आ रही है 16। टोटल कितना हुआ? 19। नाउ वी आर डूइंग mod 2 टू एवरीथिंग ना, तो mod 2 करो ना। 3 mod 2 plus 16 mod 2 equal to 19 mod 2. This equation is satisfied. If you do 19 mod 2, guys, if you do 19 mod 2, what it is? 1. If you do 3 mod 2, what it is? 1. मतलब अगर ये वाला मॉड भी 1 आ रहा है और ये वाला मॉड भी 1 आ रहा है तो बीच में 0 ही आएगा ना, क्योंकि 1 + 0 1 होता है। Everyone write agreed in the Google chat if everyone mathematically agrees with me that if the sum of first I numbers mod m is by 1 and the sum of first j numbers mod m is by 1, it means the middle part is divisible by m. Such a brilliant observation. Right, agreed. Mathematically agreed. Right, mathematically agreed. Don't just write agreed. Don't be lazy. Don't be lazy as in Kumar ke sir session. Right, mathematically agreed. Okay, great job. Nice. So, and guys, today our student has cracked offer from Microsoft, so it's very happy news for all of us. Now we will easily get Microsoft referral from the student Anukriti. Okay, and guys, whoever is in this meeting, please make sure you guys make this post reach 100 likes. Okay, this one, which is the DSOACP roadmap, very important it is. Please make sure you do it. Now I go back and yeah, Anukriti is a very hardworking girl. She cracked Microsoft offer, right? She's from October batch and she did a great job. So congratulations to her. Make sure if you have this document, you open it and you like it, so that in future I can tell Anukriti to give you referral for Microsoft. Okay. So yeah, this thing is done now, guys. Let's go back to the class. So guys, yeah, Guys, now what is the solution for this? You have understood now. Now how will you calculate? How will you calculate all the subarrays ending at index j which are divisible by m? तुमको तो trick पता चल गई ना? The trick is this. The trick is pretty simple, right? The trick is pretty simple. That I will calculate the sum of these numbers till here, till j. I will calculate their mod m value. Let's say their mod m is coming as 1. I just need to know which prefix is there. Which prefix is there whose mod m is also 1. If a prefix has mod m as 1, it means this middle part is a valid subarray whose sum is divisible by m. So I can store all these prefix sum mod m in a hash map. तो मुझे पता चल जाएगा ना बेटा. I will show it to you visually also. Coding part you can do because I assume you are a Kumar K student. You must be knowing these things very very well, right? So let's say m is equal to 2 and this is my index j, okay? Okay, guys, you are at index j. How will you know which subarrays ending at index j are valid? First of all, as I am traveling from 1 to j, I can maintain the sum of all these elements. Guys, what is the sum of all these elements? 8 plus 8, 16 plus 0, 17, 18, 19. Wait, let me check. Okay. Okay, so 8, 8, 16, 17, 18, 19, 20, 21. So guys, what is the sum here? 8, 8, 16, 17, 18, 19, 20, 21. 21. Mod 2 is what? 1. So guys, you want at this index, I just need to know which prefixes have their sum mod m as 1. Guys, whichever prefix has their sum mod m as 1, they will make the middle part as a divisible valid subarray whose sum is divisible by m. So guys, for this array, can anyone in the meeting tell me I am at index j, I calculated a sum of numbers from 1 to j which is 21, mod 2 is 1. So now I want to know which prefixes have their sum modulo m as 1. So this is a valid prefix. अरे 1 है ना इसका सम, तो 1 mod 2 क्या आएगा? 1 ही आएगा ना. तो ये वैलिड क्यों हुआ? समझ आए ये वैलिड प्रीफिक्स क्यों है? Why is this a valid prefix? Because its sum mod m is 1 which I was seeking currently. Its sum mod m is 1, it means this middle part from 2 to 7 is surely a subarray whose sum mod m is 0. So this gets counted. So number of valid prefix is the number of valid middle parts which will be given birth to. Okay. So that is a valid prefix, guys. Which is another valid prefix? This is also a valid prefix, na? Numbers from 1 to 3. This is also valid prefix. Array, because it's sum, what is it sum? 2, 3, 4. 2, 3, 4. No, this is not valid. Its sum is 4. 4 mod 2 is 0. We want the prefix such that its sum modulo m is 1. This is also not valid. So now what will I do? Is this prefix valid, guys? Yes. Its sum is 5 and 5 mod, its sum is 5, right? Its sum is 5, 5 mod 2 is 1. I wanted it to be 1 only. Because its modulo m is 1, it means this middle part from 5 to 7 will be a valid subarray whose total sum divisible by m is equal to 0. So guys, इससे क्या पता चलता है? इससे ये पता चलता है कि एक तो ये वैलिड प्रीफिक्स था और एक ये वैलिड प्रीफिक्स था, तो दो वैलिड प्रीफिक्स थे. कितने वैलिड प्रीफिक्स थे? Two valid prefix are there. So because there are two valid prefix, it means two valid subarrays will be born whose sum when divided by m will give 0. Why? Because because this prefix 1 is valid, this means 2 to 7 is a valid subarray. Because 1 to 4 is valid, this means 5 to 7 is a valid subarray. So guys, do you understand that you just have to run a for loop? Guys, react with emojis if everyone understood these things. It's nice, right? Just focusing on the middle part gets the job done. Okay. Thank you, guys. Thank you. So, let's. Mhm. Where did our document go, guys? Let's just search the document and get it done. So, guys, the you will have to write the code for this. Okay. Like it should not happen that the class is done and you did not even submit the codes and stuff. Okay. So hopefully you guys have understood this. Okay. Now the real Meesho OA question will be discussed. So be ready for that. So guys, what will be the solution? You know now? Only one for loop you need from 1 to n. Only one for loop you need from 1 to n. Now what will you do, guys? Oh lovely people, your Kumar ke sir is here only. Now what will you do? You just need to know uh, the valid subarrays ending at index j. You just need to know the valid subarrays which are ending at index j. Okay. You just need to know the valid subarrays which are ending at j. So how will you know which are those valid subarrays, guys? The valid subarrays, you know na the formula for valid subarrays ending at index j. Let me write it here as sum equal to sum plus d or p. What will be the valid okay, let's write it as count. Okay, p is the number of valid subarrays ending at j. Number of valid subarrays ending at index j. This is nothing but what? First of all, you need to make a sum variable, right? To know the sum of numbers from 1 to j. So first of all, I will write sum equal to sum plus a of j. Okay. Once this is done, guys, you know the sum, right? You will you know now that when you are at index j, you have to calculate sum of the numbers from 1 to j mod m. So sum of the numbers from 1 to j mod m is what? That is the required value which you are searching for. So let me write here. Sum of all the numbers from 1 to j mod m is nothing but sum mod m. Now you just need to check how many times this prefix has come before. You can use a hash map for that, right? So P is nothing but hash map of VL. And yeah, that's it. Hash map of VL. That's it. हैश मैप ऑफ वीएल मतलब अपना सम मॉड एम इधर क्या आया था? अपना सम मॉड एम 7th इंडेक्स पे जब जे था क्या आया था? 1 आया था ना. तो अपन हैश मैप में चेक करेंगे और कितने प्रीफिक्स है जिनका सम मॉड एम 1 आ रहा है, तो पता चल जाएगा कि ऐसे दो प्रीफिक्स है. दो प्रीफिक्स है मतलब दो वैलिड सब एरेज क्रिएट हो सकते हैं. सो once this is done, you will update in the hash map that yes, as this current index is ending, as the answer for this index has been calculated, it might help you in the future. So for this particular value, one more prefix has come. Hash map of VL equal to hash map of VL plus 1, because VL is also the sum of the numbers from 1 to j mod m, right? So you need to increase its frequency, so you can use it for j plus 1, j plus 2 till n. Okay, and guys, the problem is solved. I will be opening the Google chat, immediately write the time complexity, and we are done. And then we start the real OA question. Guys, what is the time complexity? Use your brain and write in the Google chat. Fast! Yeah, it's O of N. Great job. Congratulations. Thank you for understanding. Okay, fine. So, hello guys, with the name of God, Ram Ram. Now, the earlier question we solved on array, na same question you have to solve on a tree. Tell me the vertical path on a tree which are valid. What is a vertical path? You know how a tree looks like? Obviously, a Kumar student must be knowing how a tree looks like, right? There's a root of the tree at the top. So let's assume that we node 1 is the root of the tree. That much in detail we have not written here because we don't have the pick of the question, but you can assume node 1 is the root of the tree. Let's assume that node 1 is the root of the tree. So guys, this is the tree given to you. Immediately as I open the Google chat, everyone has to tell me which vertical paths are there in this tree. Vertical path means it should start like this and end like this, okay? It should not be in V shape or upside down V. Upside down V should not be there. So which vertical paths are there whose sum mod m is 2? So one vertical path is this only, na? 1 to 1. If you only take the node number 1, the value is 2, right? So 2 is divisible by 2. Another valid path will be 1 4 2 plus 1 3 4 5 6 7. Okay, it's not valid. Another valid path will be 1 to 2. This is also a valid path now because the sum of them is divisible by 2. So there are two valid paths. In this tree, there are two valid paths whose sum is divisible by 2. Okay. Everyone write yes in the Google chat if everyone agrees with this, that yeah, there are two valid paths. One is this one, the sum is divisible by 2. And one is this one, the sum is divisible by 2. Clear, guys? Guys, now I'll change the question. You answer that question and then we'll go ahead. Okay. Tell me which are the valid vertical paths in this tree such that their sum divisible is divisible by 3. I can see it. Can you see? And guys, for m equal to 2 also we did a mistake. Huh? Sorry. For m equal to 2, this is a valid vertical path, right? This is also a valid vertical path, right? 1 to 1 is valid, 1 to 2 is valid. But then there is something more which is valid, na? Array 2 to 2, this node alone is also valid, na? How could you forget that, man? Then 5 to 5 is also valid, na? Because node number 5 is having a value 2. 5 to 6 is also valid. Array, this much part is also valid, na? Their sum is divisible by 2. All are valid vertical paths in the tree. And then 6 to 6 is also valid. 1, 2, 3, 4, 5, 6. Guys, there are 6 valid vertical paths. Everyone write yes in the Google chat if everyone agrees with this observation, guys. Now, guys, I will open the Google chat. You have to tell me what if the m equal to 3. I don't want the total number. I want each one of you to start writing those paths. How many valid vertical paths are there, guys, in this tree such that the sum of the nodes of that vertical path is divisible by 3? Be quick, guys. Be quick. You can do it. You can do it. You're a Kumar student. Till then, I will like teach you. So lovely people, let's start the enjoyment. I can see those paths. I don't know about you, bro. I can see those paths. I can see those paths. I don't know about you people, unfortunately. See, one path is 1 2 4. See, na, this is valid. Another path is 2 2 3. This is also vertical path whose sum is divisible by 3. Another is 4 2 5. 1 plus 2 divisible by 3, na? Yeah, you cannot go like this. Huh? This V shape is not allowed, but rest all the shapes are allowed. Okay. So guys, how many valid vertical paths are there? In this two, sum is divisible by 3. I can see this one path from node number 1 to node number 4, then node number 2 to node number 3, then node number 4 to node number 5. What you guys can see? There are 3 only, right? Okay. But guys, someone is saying 4. Guys, please tell me now. Answer is 3 or 4. Dupin saying the everyone knows the answer, but understanding why it's working is important. 1445. Great job. Congratulations. 1456. 1 2 3 4 5 6. अरे तो 1456 पाथ को कंसीडर करेंगे तो क्या सम आता है रूही? कौन से दुनिया की हो तुम? ऐड करो, ऐड करो. 2 1 2 2. ये 3 से डिविजिबल हुआ. कब से 3 से डिविजिबल होने लग गया ये? Ruhi, if you take the path of 1456, the sum is not divisible by 3, Ruhi. Please learn basic mathematics. 1 2 3 4 5 6. अच्छा, क्या मैंने गलत तो नहीं बोल दिया? नहीं, सही बोला. मुझे कभी कभी खुद के मैथ्स पे डाउट हो जाता है यार, तुम लोग का देख के. जाने दो, क्या बोलूं मैं. Anyways, so I should trust that I am Kumar ke don't need to depend on your maths. So guys, this is working, okay? Everyone write 3 in the Google chat if everyone agrees that there are 3 paths in this tree which are vertically divisible. And Navlesh, you please know that this above array question you have to write the code and submit in the group, or else I'll give you penalty. Anyways, coming back to the question, guys. Okay, so now guys, there is a special way to do DFS. See, you know, the normal DFS code is doing what? If you use the normal DFS, what it does is it travels the tree in a very special way. This thing, very very special it is. Yeah, let's cut this part. So you know now, whenever we do DFS on tree, what happens, guys? Other people who are doing the thing since last few days, you guys must be knowing what happens, right? You send the node, right? Then you say this node has been used. You do the for loop for its children. If it has not been visited, then you call the DFS function of that child. Everyone write yes in the Google chat if they understand this thing about DFS, guys. Yes, it is called as top-down DFS. So guys, if you do DFS of this tree, what will be the order? Everyone tell me. You will do Rangoli, right? Boundary type traversal. I have taught this. What will the traversal give the output? 1 2 3. Then 1 2 3. Then if it goes in reverse, we don't say it again. 3 2 1 will not say again. Then 4 5 6. Then when it goes in reverse, we don't say it again. So 1 2 3 4 5 6 is the DFS order. If you do the DFS, the nodes will be printed like this: 1 2 3 4 5 6. Okay, no matter what is the tree, you should know that it always start at the top node. It goes like this, and then it travels in a boundary fashion. Just make a boundary and you get it done. Clear, guys? All clear? Write clear, clear, clear in the Google chat. Everyone, please write clear, 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 clear. Now, guys, there is a special need. You can do manipulation to this code can tell you the sum of all nodes from your current node till its all ancestors. So guys, for each node I, for each node I, you can output, you can output the sum value of node plus value of its parent plus value of its grandparent till the node number 1. You can always do it by doing some manipulation, guys. What is that manipulation? You will copy paste the same code. If you want to understand how is this working, watch that video, session number 10. But I will just tell you the trick, guys. What is the trick? Can anyone tell me? Just do one thing. Before this for loop, na, write here sum equal to, like, just declare a sum variable globally. Just write here sum equal to sum plus node before the for loop, and after the for loop write sum equal to sum minus node. Such a brilliant thing is this. When I learned it, I was overjoyed. Eureka moment. अब ये करने से मालूम है क्या हो रहा है? You know, in DFS there is one used statement, then for loop statement. But I am saying before that used statement, you write sum equal to sum plus node, or whatever the value of that node was. Let me write here value of that node. VL array tells us the value of that node in the tree, okay? And sum equal to sum minus VL of node. We have to subtract also. So now guys, what will happen here is, if you print node comma sum, what will happen? For this node, U will be printed or P will be printed. P is what? P is nothing but value of that node plus value of parent plus value of grandparent plus, till the top. Okay? No. If we send the sum variable in the function, it will just screw up everything. Never do that mistake. Just declare it globally. Okay? Or else it will mess up with the DFS function. In DFS function, the sum, if you send it in the sum function, the values will change not in the way you want, Sayarsha. Then you need deep recursion knowledge. And you guys don't have that deep recursion knowledge. पूरी लग जाएगी, फट के हाथ में आ जाएगी. तो वैसा काम कभी मत करना. सम को फंक्शन के बाहर ऊपर डिक्लेयर करना. सम को फंक्शन के साथ मत भेज देना, तो वाट लग जाएगी. क्लियर? क्योंकि जब सम को फंक्शन के साथ भेजोगे तो माइनस वाला ऑपरेशन नहीं कर पाएगा. समझ रहे हो? क्या तुम लोग को ऊपर ऊपर से समझ आ रहा है कि नीचे माइनस क्यों किया है? ऊपर सर वैल्यू ऐड किया, नीचे माइनस किया. मैं बताता हूं क्यों. अब ध्यान से सुनो गाइस. Now your DFS will print something very strange. Okay, guys, can you tell me when I am at node 1, what will my DFS function will print? Node number 1, but what is the sum? Sum is 2. Clear, guys? When you reach node number 1, 1 comma 2 na? Array 1 will be the node value. 1 will be the index of the node. And sum means the value of that node, yaar. Everyone write 1 comma 2 in the Google chat. And please be quick. Freaking quick. Fast. Okay. When you come to node number 2, what will be printed? The index of node is 2. But value is 2, but 2 will not be printed. The full sum till the parent, grandparent, add everything till the ancestor. 2 plus 2, 4 will be printed. अब समझे, अब दिमाग में घुसा कि कोई भी नोड पे रहूंगा तो वहां से लेके उसके जितने भी बापों के बाप थे उन सबका सब सम प्रिंट हो जाएगा, अगर तुमने कोड को इस स्टाइल से लिखा तो. What I'm trying to say is that if you write the code in this manner, what will happen is that whenever you write here print node comma sum na, along with the index of the node, a special sum will be printed. That sum will be value of that node plus value of its parent plus grandparent plus great grandparent plus great 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 grandparent till the value of node 1. ये जितना मैं गला फाड़ फाड़ के बता रहा हूँ, कोई तुमको बताने में इंटरेस्टेड नहीं है बेटा, समझो बात को, इसलिए पढ़ाई करो. सो दिस थिंग इज क्लियर टू यू. नाउ साहेब राव जादव विल ओनली टेल मी at node number 3 what will be printed. Sahib Rao Jadhav ji, quickly tell people are want to go to court chef contest. What will be printed? चलो दूसरे लोग तो लिखो, साहेब राव को छोड़ो, तुम लोग लिखो. 3 is the index of that node, comma sum from here till the top. So 1 plus 2 plus 2, 1 2 3 4 5. अब ये बात सबको समझ आ जानी चाहिए कि मैं डीएफएस में कहीं भी उठ के आ जाऊं, एक झटके में मुझे पता चल जाएगा इसके और इसके सारे बापों का सम क्या है. गाइज अगर मैं नोड नंबर 6 पे आया हूं डीएफएस फंक्शन में, तो क्या प्रिंट होने वाला है. गाइज इफ आई एम एट नोड नंबर 6 व्हाट विल गेट प्रिंटेड. 6 will get printed its index and the sum till the top. 2 plus 2 plus 1 plus 1. 1 2 3 4 5 6 7. 6,7. Everyone understood this trick. If you write the code in this fashion, na, at the top you do sum plus no, value of node, and at the bottom you do sum minus value of node. So this is gonna work. Okay. If you want to understand it deeply, go work, do some work. I'm screaming since 20 days that beta go and watch 3 videos. It's your monumental laziness that you have not done that. That's why I don't know these things. So go and watch 10 3 videos from the course. Don't ask me where they are. Now, everyone write yes in the Google chat if they know how to search tree course videos and how to watch it with the eyes. वो भी मैं सिखाऊं, आँख खोल के वीडियो कैसे देखते हैं कि वो आता है तुमको. Great job. Now, let's start the job, guys. Yeah. So, guys, now how will this knowledge help us in solving the actual question? In actual question, if you are at node I, you already know the sum of the node plus all its ancestors. You already know that. Let's take a very big tree, okay? A very big tree, okay, guys? A very big tree. And let's say we are not writing the whole tree, a very big tree. You are at node number J. This is node number 1. Guys, if I do DFS and if I reach node number J, can I know the sum of all nodes from 1 to J in this order, in this vertical order from 1 to J? Can I know this sum? Just write yes or no in the Google chat. Can I know this sum from 1 to J if I am doing a very special level DFS? If I am at node J, can I know the sum of all the nodes of its parents till node number 1? Yes. So guys, this is the same thing na? In normal array also. Just imagine this as an array. Can you imagine this vertical path like an array? Yes. So the sum of this vertical path, you know that from 1 to J, what is the sum? You know how to calculate that. Now you just need to know how many, whatever is sum is not, do it mod m. Now, for all these prefixes, you just need to know how many prefixes sum mod m is equal to your sum 1 to J mod m. Right? Brilliant in the Google chat if the people have understood what's happening here. Just like earlier you were doing in the array, na? This time when you reach at J, your array is nothing but the full vertical path from node number 1 to node number J. From node number 1 to node number J, you already know that sum from 1 to J. Just calculate it mod m and now do the same trick. Now do the same trick. Now what do you want? You have calculated sum 1 to J mod m. Now you just want to know how many prefix above you are having the same values. You can know that from the hash map, right? अब बस तुमको ये जानना है, समझो m की वैल्यू 2 थी. m की वैल्यू क्या थी? 2 थी. m वैल्यू वाज 2 and sum from 1 to j mod m is coming as 1. अब तुम बस ये जानना चाहते हो कि सर, हाँ बोलिए, ऐसे कितने प्रीफिक्स है जब जिनका सम मॉड m करेंगे तो उनका भी वैल्यू 1 आएगा, तो वो सारे वैलिड, दे ऑल विल जनरेट वैलिड पाथ्स. व्हाई? Because if this much part sum mod m is 1 and the whole sum mod m is 1, it means this middle vertical path is divisible by m. Such a brilliant thing this is. Done. Problem solved. So guys, what you need to know? Obviously, at each node you need to know what? You need to know the sum. At each node j, I need to know the sum for it and all its ancestors. And also I need to maintain a hash map. I will declare a hash map globally. Hash map will maintain for all the nodes from 1 to j all the prefix sums mod m which have come till now. So that's it guys. It solves the whole problem. Okay. Right? Yes, yes, yes in the Google chat guys. Yeah. So the thing is that अब ज़्यादा कुछ नहीं करना है, यही करना है जितना समझाया है, अच्छे से समझ के कर देना. I will write the explanation here as well, but try to submit all the codes after the class. Okay? Clear? And yes guys, but write same trick in the Google chat. तभी मैं छोड़ूंगा. Same trick मतलब इधर कैसे ऊपर सम के साथ नोड की वैल्यू को ऐड कर रहे थे ऊपर, वैसे ही इधर याद रखना जब हैश मैप डालोगे ना तो इधर हैश मैप में जो भी चीज डालोगे सम का मॉड एम वो इसमें ऐड करना, और जब निकलोगे ना तो वही चीज को हैश मैप से रिमूव करना. समझे? सो ट्रिक चल जाएगी इफ यू यूज लॉट्स ऑफ योर ब्रेन. इट्स अ नाइस ट्रिक राइट? या